Hello students, today we will be discussing about chain rule. This is a part of derivative. To get the detailed video of the derivative, just see the description. Okay. Now, chain rule. What is chain rule? We have already discussed that there are different forms of derivatives: exponential form, logarithmic form, trigonometric form. But this is a part of the derivative, that is chain rule. What is chain rule? We will explain this chain rule with some examples. Suppose we know ddx of sin x, ddx of sin x, that is cos x. We know this formula. ddx of e to the power x equals to e to the power x. Okay, these are the normal formulas. But if we have to find the derivative of ddx of e to the power mx, what will be the answer? What will be the answer of this ddx of e to the power mx? We can say that e to the power mx means e to the power mx by comparing these two formulas. Okay, e to the power mx will be e to the power mx, and this mx we will again differentiate this mx, that is into ddx of mx. Why? If there is only x here, the power of e is only x. So while differentiating e to the power x, we are getting the result, that is e to the power x. But whatever the power may be other than x means it may be the coefficient of x, or it may be multiplied with x, or it may be any other function other than x, we have to separately differentiate that function. Okay, see, it's not x, it is mx. Therefore any function other than x will be differentiable again. Now see, m is constant, we can write m into ddx of x, that is m into ddx of x means 1, that is m. Therefore the answer of ddx of e to the power mx will be e to the power mx into m. This is chain rule. Okay, this is chain rule. That is, if there is any function other than x means, that is, the variable is not changing. The term other than x I am using, that doesn't mean that variable is changing. That means any function except x. That means, suppose sine of mx, okay, just see, while differentiating sine x we got the value cos x, but now while differentiating mx, this is not only x, something is multiplied with x. Okay, something is multiplied with x, therefore it will not be only it will not be only cos x. Okay, since we know the derivative of sine x is cos x, okay, therefore the derivative of sine mx will be cos mx. But no, there is m is multiplied with x, therefore it's a separate function. Okay, here it is separate function. Here there is two function, just concentrate, there are two function. The first function is sine, that is the trigonometric function, and the second one is mx, therefore two functions. We have to differentiate both the functions. Okay, and this is chain rule. There may be more than two functions. Okay, just see, first we will concentrate, that is sine, the trigonometric function. ddx of sin x will be cos x. Now just write cos x, that is cos of mx. Here it is mx, so we will write cos of mx. Now there is not only x, there is mx. Okay, now this is the second function. Why second function? If there had been sin x, if there had been only sin x, the derivative would have been cos x. Okay, but since there is sin of mx, therefore there are two functions associated with this. The first that is the sine, that is the trigonometric function, and mx is the algebraic function. Okay, now we will concentrate first, that is sine x. ddx of sine x will be cos x, therefore cos of mx, since here it is sine of mx. Now since m is multiplied with x, x is not alone, therefore we have to again differentiate mx. Therefore we will write into ddx of mx. Okay, now just see, the answer would be cos of mx into m. We have already found that the ddx of mx is m here, therefore we are writing only m. Therefore the derivative of sine of mx will be cos mx into m. Now we are taking some more examples to clarify this part. Okay, number 1, sine x square plus 5. Okay, again we know the differentiation or the derivative of sine x is cos x, but here it's not x, here it is x square plus 5. Now there are two functions. First we will concentrate for the trigonometric function, that is sine x, and now it's not x, therefore it's totally a different function. Okay, so there are two functions, one for sine and the second for this algebraic function, that is x square plus 5. So first we will concentrate with the trigonometric function, that is sine. We know that ddx of sine x square plus 5 will be cos of x square plus 5. Okay, now since there is not x, it's x square plus 5, then since it is a completely different identity, okay, if there would have been x, it would have been cos x only. Since there is x square plus 5 in place of x, so we have to separately differentiate this x square plus 5. Now into ddx of x square plus 5. Okay, now ddx of x square plus 5 means I am separately doing this here, x square plus 5, ddx of x square plus ddx of 5. ddx of x square will be 2x. We know the formula of x to the power n, that is n x to the power n minus 1. So this is the formula. Since it is the power will come, this is 2 minus 1, that is n minus 1, plus ddx of any constant. 5 is a constant number, therefore ddx of constant will be 0. So ddx of x square plus 5 will be 2x. So we can write over here, that is cos of x square plus 5 into 2x. Okay, so this is the derivative of sine x square plus 5. Now we will move towards our next example. The next one, sec tan of root over x. Now students, how many functions are there? You will say there are two functions, one is trigonometric and the other is algebraic. No, there are three other functions. Why three? First we will see that sec. If it would have been sec x, okay, the ddx of, therefore ddx of sec x means sec x tan x. Okay, we know the formula, but here it's not x, here it is tan of root x. Therefore the theta or the x here is replaced by tan of root x. Therefore it's a totally different function. Okay, so we can say that for sec of tan root x will be sec of tan root x into tan of tan root x. Done? But no, there is tan of root x. Therefore we have to separately differentiate tan of root x. Now just see the first step. ddx of sec tan of root x. Just consider this whole tan root x as x. We can consider this whole tan of root x as x. Therefore what will be the differentiation of sec of x? We know the differentiation of sec x is sec x into tan x. We will replace x with tan of root x into tan of tan root x. Okay. Now, this is not x, this is tan x. So we have to separately differentiate tan of root x. Therefore, d dx of tan root x. What is the differentiation? What is the formula of differentiation of tan x? Tan x, the differentiation of tan x is sec square x. Okay. Now, d dx of tan x equals to sec square x. So, we can write tan of root x means sec square x, but no, it's not x, it's root over x. Therefore, the third functions come here. Now, just see. Separately, we can write sec of tan root x into tan of tan root x into sec square root x. Okay. Now, this is root x, not x. Therefore, we have to separately find the differentiation of this root over x. Okay. Root over x means, what is root over x means? X to the power half. Okay. Therefore, into d dx of x to the power half. What is the differentiation of x to the power half? That is, d dx of x to the power half means half x to the power half minus 1. Comparing the value of x to the power n, that is n x to the power n minus 1. Okay, so this is the formula. And therefore, we can write sec of tan root x into tan of tan root x into sec square root x into half x to the power minus half. So we can again write minus half means that is 1 by root over x. So this is the differentiation of sec of tan root x. Just pause the video and note it down. The next example is sine square x to the power 5. So this is our function. Okay. So how many functions are there? First of all, we will see that the sine. Okay. There the square, that is the power. Okay. And then x to the power 5. So there are three functions. First we will concentrate with sine. We know, first we will concentrate with the power of sine x. Therefore, power means we know that d dx of x to the power n equals to n into x to the power n minus 1. Okay. Similarly, here it's not x to the power n. Here it is sine square x. Okay. So similarly, the power will come forward. That will be 2 sine x. Okay. That will be 2 sine x. So first of all, we will concentrate with the power. If there would have been x square, the answer would have been 2x. Okay, but here it's not x, here it is sine square x. So we will separately differentiate this sine x. Now the first step, d dx of sine square x to the power 5. First of all, we will see that the power comes forward, that is 2 sine x. Okay, but here it is not sine x, here it is something different, that is x to the power 5. Okay, and here sine x, therefore we have to separately differentiate this sine x. Okay, since it is not x, that is it's not x square, therefore it's anything other than x square, that is there is sine square x. It's totally a different function, but we are concentrating with the power. In case of differentiation, we know that while differentiating any x to the power n, the power comes forward, and that is x square, the power will come forward, and the power here it will be n minus 1, that is 2 minus 1. Similarly, here it's sine square x to the power 5, the power comes forward, that is 2 sine x to the power 5. And since it is sine theta, it's not x, Therefore, we will separately differentiate this sine theta, that is into ddx of sine x to the power 5. Okay. What will be the differentiation of sine x to the power 5? We know that the differentiation of sine x is cos x, and therefore the differentiation of, just concentrate or just substitute this x to the power 5 as x, normally x. What will be the differentiation of sine x? It will be cos x, simply cos x. But in place of x, we will write x to the power 5. Nothing more than that. Now, therefore, 2 sine of x to the power 5 into ddx of x to the power sine x to the power 5 means cos of x to the power 5. Okay. Now, it is not x, it is x to the power 5. If it would have been x, the answer would have been end over here. But since it's not x, it's something other than x. It's a different function from x. Okay, so we have to differentiate separately this x to the power 5. Now we will write that is ddx of x to the power 5. That is 2 sine x to the power 5 cos of x to the power 5 into 5x to the power 4. So this is our last answer. We can also write here substituting this x to the power 5 as theta, or considering x to the power 5 as theta, we can write 2 sine theta cos theta means sine 2 theta. That means we can write sine 2 x to the power 5 into 5x square. So this is the formula of sine 2 theta. We know that 2 sine theta cos theta equals to sine of 2 theta. Just we are considering this x to the power 5 as theta. Therefore, 2 sine theta cos theta, that is sine 2 theta, or here its theta is replaced by x to the power 5 into 5x to the power 4. So this is chain rule. Okay, so this is all about chain rule. Okay, students, thank you.